Okay, so Dave Colombo here tonight. We're working on a Piezo transducer that we're going to actually turn into a receiver to see how we can pick up underwater sound. So what we have today, we've ordered up some different parts. I'll show you the parts and then I'll come back and we'll show the assembly of what we're doing. But the idea is to take a Piezo disc and I actually have one here that we ordered. They cost about $1 a piece. And we're going to take them and enclose them in a chamber of acrylic with about an 1/8 inch air gap. So we have a fixed resonant air chamber. But we want the disc itself and the connections to be waterproof. So I got some unique things we're working with there. So let's take a look at what we got. So right here we're starting first off with a 36 millimeter Piezo disc, which has a ceramic center in it. And we've soldered into a version of one our two contacts. And you might notice the tinfoil leads that we have on there. Those are actually a twist tie. A twist tie that I picked up off of something. I realized I had a wire and I'm surrounded by a piece of mylar. And so the mylar is thin, it's flexible, it gives a little bit of shielding, but also gives us some area to glue to. So when we use the acrylic solvent cement to glue the two pieces of acrylic together, it hopefully will create a watertight bond. So we checked the conductivity, and the mylar itself does not conduct, but the wire inside does. And you can see I'm still learning to solder on top of brass, but so we have that first. Then we also have this 1/4 inch piece of acrylic. We're going to be using that for a back. And then we have this 1/8 inch piece that we've carved out the center section. We did a slight reveal on the back side so that it gives us an area for the disc to lay underneath without lifting up the edge of the acrylic. And then you'll notice that there's two kind of grooves that we've carved in there, and they're just basically enough to reveal to handle where the solder joint might be here, and then also enough so that the wire can actually just start to get underneath it, so when we compress it, hopefully it'll compress down tight, the solvent will fill the void when they glue them together, and we'll have a watertight bond on this. The third part we're using is a piece of polycarbonate. Now this is a pretty flexible piece. The idea is that this is the receiver side that is exposed to the water for vibration purposes. And so I want something it's about 1/16 inch. It's pretty flexible, but when we glue it to this ring, we'll actually have only a space as big a diameter as what the 36 millimeter is of span held by a rigid joint around the perimeter. And so we may find that it's strong enough to give us the strength we need so it doesn't deflect in at depth, and yet still give us enough flexibility to really transmit sound through. So here's what the assembly is going to look like. So we're going to start first with this 1/4 inch piece of acrylic. We're going to glue the Piezo disc on top of that, and then the ring that we have here will sit on top of it like this, centered up. And then we're going to glue on top of it this piece of acrylic, but before we do that, we're going to go ahead and peel off the protective plastic that's on there, and then we'll be gluing that on top of, let's see, it's actually got two sides. So we'll taking that piece of carbonate, and we'll be gluing that on top. So we'll be able to see inside to see if there's water inside of it, and we'll also be able to see if it comes loose or if we lose a solder connection. And hopefully it'll work. I did a quick test earlier to see if in fact we had conductivity, and hooked the two leads up to an amp that I have, and we're able to get really sensitive reactions to it. So we're real curious to see how it's going to be when we get it all glued together. So we'll put it together and we'll show it to you when it's done. Okay, so here we are, completely assembled Piezo disc encased in acrylic with a carbonate front on it, and we just ran a quick test and it seems to be working okay as far as transmitting sound. So now we'll stick it in the water and see what we can actually hear with it, see if it actually receives as well as we hope it will. So we'll give that a try. Okay, so we've got the Piezo disc all set up inside of the plastic here. It's sealed up. We've stuck it in the water a couple times. It seems to be working pretty good. It's not leaking. That's a good sign. So we've also got a couple things. We're going to do a real scientific test here, right? So we have a bucket full of water, and what we're using is a little amp that I picked up from China. It's a 60-watt amp. It's got some cool little lights on it that make it kind of funny, but it's got a bass and a treble component to it, which we'll use for gain controls. And then here on my laptop, you can see that I'm running here a waterfall spectrum analyzer, and you can see that right now we're getting no pickup. There's nothing coming in. There are some vertical lines which are interesting. Not quite sure what's causing that. And then over here we have the Audacity program, which we're going to start up here now. So let's get that started first. We're going to go ahead and tell that to start recording. And you can see it's actually got a real fine line down there. It's not doing much of anything at the moment. So let's take and shift this up. So we can't get a bigger screen. Okay, like that. Alright, and so I'm going to look over here to where the thing's at. We're going to go ahead and click it on. So I want you to watch the screen. You can see when we do that. So we're going to click on. And you see we got a big spike there. That's the power coming on to the transducer. And now we're starting to see a pattern come across here that, believe it or not, has to do with the gain on the amplifier. We're not really picking up signal so much as we're getting feedback from the amp. So we're going to turn this all the way down, turn the bass all the way down, and we're going to have the treble all the way to the bottom. And we'll look back again. You can see that our line is pretty consistent. There's an occasional wavy pattern which I've come to realize has to do and coordinates with this cool looking blinky light that we have. So we're going to disable that here because it's actually causing a feedback issue. But for the moment, we're going to turn our treble up so we can see that. And we're going to take our handy dandy little disc here, and we're going to drop it in the water like that. And we should be seeing some differences on the frequencies. Now it's real minor at the moment, so let's go ahead and kick the amperage up. So two things happen. You can see we're starting to pick up some background noise from the amp. Now we'll go ahead and blink it in the water a couple times and see what happens. So you can see we're getting some different movement like that. Now I'm going to just take and drop a handful of water from the top side. It's dripping in. You can see that it's actually creating a spike on there. The other thing you'll notice on the spectrum analyzer, there is a series of same patterns that are repeating over and over again at a particular interval, and I think that has to do with the fact that again, the lights and some type of timer system that's on it. So I have to figure out how to eliminate that. So overall, it seems to be working pretty good. So tomorrow we'll be taking it out to the lake, see what we can hear with it, and record some sounds and see what how she does. So for our bucket test here, back to the spectrum analyzer and our Audacity program, we're done for the night.